Here we go. We should be, but there's no guarantees. And I don't think that worked actually. I'll try that again.
It did work before.
It did work. I
Yeah.
just can't see it. Okay, so I'm going to have to put it on my screen as well. That was clever of me. I managed to find a way of letting you see it without me seeing it. Ah, okay. Are you now? Oh, I am looking at it as well. You're looking at Canvas site? Okay. So let's tell you what's going on here. A lot of people, because they've done other online classes with Canvas, is that they think Canvas is where everything happens. Actually, not really. Everything happens as far as assignments, and most of your tests happen in WebAssign. That's a little bit different, unless you've done WebAssign before. What Canvas is for information. That's where I put all the stuff that is there to help you. So if I start with this one, and I click on welcome, it'll tell you about me.
Hey, Professor.
Yes.
We're actually on WebAssign.
We are. Shooting space. Did you see how I didn't swear there? I'm good. Let's try this again. There. Are you looking at it now? Is this Canvas? Does it say welcome to Math 151? Okay.
Yep.
Thank you for telling me. I have two television screens, so it's not always obvious to me which one you're seeing. So we're all on it now. So here, I'll close this off again. This is all of the Canvas stuff. This is a student view of it, at least. You'll click on this guy here if you haven't already done so, and you need to join WebAssign. Here is our class key. This key gets you into our class. Nobody else gets into that. And here are the instructions, and hopefully you'll figure that out and you'll get in. Next is Zoom. Well, the fact you're here, I guess you figured that out. These two are to do with when you've done your test. You do your test in WebAssign, right? You write the answers into WebAssign, which is a piece of software, but I get to see your working, right? So you've written down what the working looks like in paper. And this software here, called Adobe Scan, allows you to use your phone camera, and it turns it into a PDF, and then you upload it into Canvas and you send it to me. And you can watch the videos and it'll tell you what to do. And then this middle one is basically your day-to-day stuff. This is the office link to Zoom, or office Zoom link, I guess I should call it. 10 o'clock every day. So if you want to see me, you click on that and it's a Zoom thing. So it's a bit like going to my front door, you know, knocking on the door and I'll let you. And so you have homework questions, whatever, that's a good time to see me. That might not work for everyone, which case you email me and we'll figure out a time where I'm free and you're free and we'll do a Zoom meeting, a one-on-one then. So that's how officers work. You click on this. Here is the Zoom link that you all were sent by email, right? This Zoom link is the same Zoom link that will be for this class all the way to May the 21st, because that's as far as Zoom would let me do it. And then I guess on May the 22nd, I'll generate a second one, right? So that's the guy that you'll use to get in. And I think it's pretty self-evident. And I forgot to show you something. So I'll go back in. Every Zoom meeting, including this one, is being recorded. If for some reason, and you're totally entitled to, do not like your picture or you to be on a Zoom meeting, then I will have to arrange a editing process so that you don't appear anymore. But most of the time you won't appear anyway. It'll be what I'm writing and what I'm saying. So your lessons will go here and there will be a video and you will click on them, and it's a YouTube link because I have a YouTube site, and you can watch every class. And why is that helpful? You might miss a day because you're at the dentist. You can go back and see what you missed. I might say something and you've forgotten what it was, but you know it was important. Well, couldn't you go back and just jump to the bit and listen to it again? For instance, tomorrow especially, I'm going to be using the TI-84 calculator to show you how to do some calculations that are a bit messy, a kind of shortcut way to doing that. And you might want to watch the video 2 or 3 times because it's, you know, you hit this button, then you hit that button, then you do this, and then you do that. And there might be just too much happening and you want to see it, right? So you can, the great thing about, well, can't you just pause it, you know, and okay, wind it a few seconds, play it again, okay, got it. And it's for things like that. So it's a resource. You may never look at it at all. I mean, I don't know if you look at it or not, but it's at least it's there, right? If you need it, it's a resource. Here are all the homeworks that you're going to do. They're in 2-week chunks because the way I do things is you do 2 weeks and you get a test on the 2-week stuff. 2 weeks, test. Got the gist? 2 weeks test, 2 weeks test, final, right? It's got pretty straightforward structure. So how's this going to work? All of these things are in WebAssign, which you'll see in about 5 minutes from now. When you click on WebAssign, there are questions on the tangent velocity problems. There are questions on using limits, laws of limits to solve limit questions, right? And you do your homework and 20% of your grade will be in this. But you have until midnight of the 18th to do all of these. I strongly suggest not today because today's a special case, but normally after we finish a lesson, it's a good idea as soon as you can to go on WebAssign and do the stuff from that section. It's fresh in your mind, plus it'll allow you to figure out, did I actually understand that lesson? Because you'll do stuff and you'll nod your head, but you don't really know if you know until you actually are given questions and you have to answer them. And then you suddenly say, maybe I didn't understand it as much as I thought I did. So it's a way of improving your learning. And that's it. While I'm at that, it just came to me. On WebAssign, there are features like links that you click and it says, ask my professor. And there's a link or a click or whatever it is, I'm not 100% sure, that says, ask for an extension or whatever else. Don't use them. I never see those things. They disappear into the ether. There's probably a setting in WebAssign that I've never found that you set it up and it redirects it to my email. But even if it did, I probably wouldn't use it because it would get blocked probably by the filters that Olympic College use, so we don't get inundated with junk mail. So the whole thing's just a disaster. So don't use it. Just send me an email the good old-fashioned way, asking me whatever it is you want to ask me. You can use Canvas because Canvas is my email, right? It works that way too. So just telling you up front, because I don't want you to think, I've sent him 15 blinking things and he's never replied to one of them. Well, if you did them all in WebAssign, you're right, I'll never even see any of them either. So it's not like I'm ignoring you, it's just like I don't even know it's happening. So you might say, why am I doing that? Because I did get an irate student who did that once. And I said, didn't you read the syllabus? I told you not to do it. So now I've told you, all right, you can't blame me if you forget and try and communicate me with the way I can't see you. Okay, I'll pause at this moment. Do we have any questions up to this point? Does it seem like you can go on Canvas and use your common sense and figure out what's there, what you want to use? Good. Let's see what else we got. If you click on this one, chapter 2, what I have here are some more resources. What do they look like? Well, if you click on this one, I'll have PowerPoints. I haven't filled it because I guess I didn't have time. If you click here, good, I have some stuff. Here, for instance, are some notes I made on the tangent line problem. And some people like to read math, right? Some of your visual, you like to see it. Some of your audio, you like to hear it. Some of your hands-on, you like to touch it, right? And some of you like to read it, right? So I try to do as many ways as I can. Kind of hard to do the touching one visually, but apart from that, I can do most of them. So here is the tangent line problem, right? So I've got some notes there. As good as I think I am, or at least my wife will tell you I'm arrogant, but all Scottish people are arrogant, so that's normal. I have put other videos of other people doing the same kind of thing. So you might not, it might not click with your brain works, but maybe the way she did it, or the way that she did it, or another video, the way he did it, right, would make more sense to you. So I guess it's just a resource, right? So if you click on it, you watch a video, 16-minute video here, 11 minutes there, so you know how long it's going to take you. It's another resource. I think that's good. Okay. Desmos is kind of cool. You can use your TI-84 calculator to sketch things. But I think just Desmos does a much better job. See how quick it is? It's colourful. You can zoom in, you can zoom out, and you can move it around. And what more do you want of a piece of software? Is that not cool? And if you look really carefully and you click on a point, it'll even tell you the coordinates of where the two things intersect. Couldn't that sometimes be helpful? So it's a piece of software called Desmos. I like it, so I put it there for you. It's a resource that you can choose to use or not. Right. If you click this little guy down here, it allows you to put in absolute values. It should be square roots, but I've got a thing in the way. I'll try and move it out of the way. There we go, square root, pi, stuff like that, right? If you hit functions, you see you can put in inverse sines, inverse cosine functions. That's sometimes useful. Right. Well, I don't want to do that, but you could. Right. Leave that alone. So that is almost everything on Canvas, except one last thing, the syllabus. Normally in your first day, you'd be sitting in a seat and I'd hand you out on a piece of paper, right? It's a PDF. So you need this stuff. You need a webcam, not your cell phone. A real webcam. Cell phones are notoriously twitchy. Here are some important dates. Notice the days where all your tests are. Notice your final. Monday the 26th, right? This month, Monday 26th, there will be no class. I'm taking that day off. I get a personal day a quarter. That's going to be mine. Do not say Mr. Robertson said that the whole college was closed. Your English class is still going on Monday, right? And your physics class is still on Monday. Just, I'm not there on that Monday, right? Be very clear about that. On the other one, that one is a holiday and everybody's missing, right? So the Friday is I can't remember, is it Memorial Day? Forgotten what American holiday is. It's a holiday. You'll be off. You won't care, right? You get a day off. And that one is a holiday, but only for math, right? The rest of your classes are there. Talked about all your homework sections, right? Don't need to do that again. Coming to class, 10% of your grade. There are 50 class days. Essentially, you get 2 points for each. That 100 points gets you 10% of your grade. So if you turn up here every single one of those days, you're getting 10% right off the top. Of course, if you miss half of them, you're going to get 5%. And if you don't turn up at all, you'll get 0%. So come to class. So how will I know if you're here? In about 25 minutes from now, I'm going to ask you to say hi. And you're going to do it by texting it. And I will take that and I'll use it to do a register. That's how it works. So I know first day you don't know this, but will you make sure that your name is Sabrina S or Gabriel or Aina? Don't call yourself Pussycat 42 because I won't know who Pussycat 42 is. And so next time you come into Zoom, by the way, nobody in this class is called that, but just to give you an idea, make sure that I know who you are. Otherwise, I won't be able to give you the attendance because I don't know who, whatever it is. 20% of your stuff is homework, and we're going to go to WebAssign in a few minutes and we'll show you. There are 5 tests, but I keep the best 4. And your tests are going to be on WebAssign, but I will see your working as PDFs, and we'll talk about that closer to the time. Your final exam is 40%. And there's some extra credit. So if you've done the Gen 97, I think it's called, it's basically just a very short Canvas class that shows you how to do Canvas and the features, like sending me emails and so on. You send me a copy of your certificate and I can give you some points. You add it all up and you get your grades, and this is all the good stuff. And that's me now finished with Canvas. Has anyone got any questions before we move on to look at WebAssign?
So if we have the Desmos calculator, are we going to need to get a TI calculator also?
I've only used Desmos for graphing, so your answer to that question is going to be vague. Let me put it this way. Can you do normal TI 84 multiply, subtract, divide type calculations in Desmos?
I think so. Desmos also has a
Sabrina's nodding, so I'm taking it she knows how to do it, right? So yes, you can use that.
All right, cool,
I will be showing it in a TI-84 because I'm old and I know how to do it. I guess I should learn how to do it. I might ask Sabrina to talk me through how to do it. If it's cool, I'll use that instead. Is it easy to do?
Yeah. It's a breakout. They've got a different scientific calculator app, but it's also Desmos.
Oh, so it's not Desmos itself, but it's Desmos calculator or something like that. Yeah. Could you send me a link to that, Sabrina? And I'll look it over. Because if it's easier to do that way, I may change my plans and just do it that way. Because then you don't need to worry about getting hold of your calculator because it's there. In the tests, you'll be able to use it anyway, so it's not like it'll be forbidden. So you'll be able to use it during your tests as well. Now, I'm glad I asked that because no one mentioned that before. There are all sorts of things I'm thinking that Desmos probably does that I don't know. But it's fun to learn, so I like learning. So that'll be good. Okay, I'm closing this one off, or shutting it down, whatever you want to call it. And we're now going to go and look at, I get 2 things I should be doing. Right, so someone said they've already got a different scanner app. Can I use it? The answer is yes. Some of you might even have a scanner, on your printer. It does scanning. Can I use that? Yes. Adobe Scan is just, something that's there if you don't have any of those items, right? So if you can make it so that your working be turned into a PDF, you are allowed to use that instead. So don't feel that you need to learn some new software or whatever. Right, now I am going to look at WebAssign, and we are going to keep our fingers crossed that I picked the right one, right? And I'm clicking on it now. Are we looking at WebAssign? God in Himmel, I did it right. Okay, let's get this out of the way. I think I'm on student view. So this is essentially, well, this actually isn't your class, but my other calc class is identical to this, so I can use this. Can you see the homework? Right.
Yeah.
This is 2 weeks worth of homework. Do not wait until Sunday, 8 p.m. and think you're going to get it done by midnight and then send me a poor email saying, oh, blah, 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 I need 2 more days. I've given you 14 days to do this virtually, right? If you can't figure out a couple of spare days in 14, then you probably shouldn't be doing Calc 1 because your schedule is far too busy, right? So get these guys. Plus, if you do them early enough, you can shoot me emails saying, I don't understand how to do, insert question here, and I have time to do it. You can't really send me an email at 10 p.m. at night and think I'm going to be sitting by my computer on Sunday waiting for students. Right? That's too late, right? So get your problem sorted out before then. Let's pick, that one is basically an intro to how to use WebAssign, so you can do that yourself. Let's pick this one. I'll click on it. I want it to appear. Hey, good. This is basically what your questions look like. I've used that with another class. That's why there are a whole load of crosses here. So let me pick a different question. Let's suppose I was doing this question, and you don't need to worry about what it is. But essentially, you type in your answers. And I'm typing in random garbage. Right. I won't do the rest. And this guy I've decided is 42. And this guy is 120. And then you submit your answers. And it tells you you're wrong. But of course, if you're right, it will tell you that you're right. And you get 5 shots. So hopefully, if you make a couple of mistakes, you could just fix the 2 that you got wrong and you get it right. So basically, you do a whole load of working on paper, but the only thing WebAssign really wants is the final answer. And for the first few days, we are going to be doing number crunching with calculators. So you'll be typing in 42, 3.17s, and so on. I don't know how much more I need to dwell on WebAssign. I think it's kind of self-evident that you get a question and then there's a box for the answer. Sometimes the answers are not boxes, but here are 4 pictures, pick the right one, in which case there's a little circle and you hit the dot and that says I picked that one. And sometimes the answer is a little pull down menu where you hit it and it gives you like 4 different choices and you pick the word that works. Like this thing converges, this thing does not converge, this thing, this thing and this thing. When you do the WebAssign intro, it will show you examples of the different things that you can do. You can actually, in WebAssign, also draw straight lines on graphs. So it does have that feature. So there's tons of things to do, but essentially it's just like doing homework in a book, right? The way you always did your math homework. But when you did your math homework in a book, wouldn't you be writing all your work? And then at the end, it was 42 and you might put a circle around it just to remind you that's the final answer. Well, in WebAssign, don't you just write down 42? Right? The working still has to be done, right? Because you're not going to do it in your head, right? But all WebAssign looks for is the answer. It makes it a little bit harder if you want to use it to revise, because all you'll see is the answer, right? So it's probably more important than normal to hold on to your homework working and staple it together in section 2.1 and section 2.2, because come the test, you can go and look at those to help you answer questions. Right? I remember doing one with tables. I'll go and look at how I did it, and if you write good notes, good working, it will make that question a lot easier to do. Are we good with WebAssign? Last chance, any questions? Otherwise, we're going to get started on our first topic. Is everybody getting used to the way I speak now? Have you noticed that you don't notice it anymore? Still too early? Maybe by Friday you won't notice it. Okay. Let's I got a chat. Maybe somebody's going to tell me something like whatever. Oh, Sabrina has given that link to everybody, the Desmos thing. If you can hold on with me for a few seconds, I'm going to take that link and save it. Just give me a few seconds. Oh, shooting space. It's okay, it's saved. Thank you, Sabrina. You don't need to send me an email now. Right. Now we're moving on to the next scary part, and go. You should be looking at my hands. Right. And for those who are easily distracted, this is used to belong to my dad. This is a ring. It's a family ring. And this is my wedding ring. And I don't know if you can see it, but can you see a heart with two hands on it? It's kind of old. That blob in the middle, maybe if I turn, I'll get it. Different angle. Yeah. Okay, trust me, it's a heart with two things. It's called the code that. And this is Rangers Football Club. If you live in Scotland, 90% of you who are football supporters either support Rangers or Celtic. And Rangers is my team. And it's like a family tradition. Everybody in your family supports Rangers, and all your grandparents and their parents supported Rangers, and all my nieces and nephews, for the most part, also support Rangers. So it's a kind of hereditary thing as well. Okay, so let's get started with our topic. We've done the introduction, check. Let's look at the tangent slope or tangent line problem. It's a very simple problem, but it generated calculus. So it's kind of fascinating how solving one problem generated such useful mathematics. So I want you to imagine that we have a curve. And we'll call this curve, I had a blue pen somewhere. This will do. And this curve is y equals f of x. And we are interested in that point there, P. And we are interested in its tangent line. In particular, I want to know the slope of that tangent line. And that's called the tangent line or the tangent slope problem. I want to find the exact slope of the tangent line to the curve. It's actually a function as well. Y equals f of x. At the point P. Well, you might think, how hard can it be to find the slope of a tangent line? I know how to find slopes. You want to find the slope? Don't you just find the rise and you divide it by the run? No biggie. Hey, that's that tangent line you're talking about. I guess I could pick a dot here and pick a dot here, and then couldn't I just add in some extra lines? Remember making those little right angle triangle things? Wouldn't the distance from here to here be what we call the rise? And wouldn't the distance from here to here, wouldn't that be the run? Shouldn't I just find out what that number is, and divide them? And hey, I've solved your problem. What's the biggie? Well, there is a very important biggie. See this tangent line? If I gave you this curve, right? If I just copied the blue curve in these two lines and I sent you all a photocopy of it, or an email, whatever, and I asked you to draw the tangent line, would every single one of you do the same line I just did? No. Wouldn't some of you be a half a degree steeper, 1 degree shallower? Right? So the question is, which one of all those, mine or yours, is the real tangent line? Isn't that the first problem? Right? So there's just problem number one. Problem number two, let's suppose for some reason or another that we all agreed that this one was the right one, whatever that meant. When I have to find the coordinates of these 2 points. Right. Now, it would be a miracle if these were numbers like 5,7 and 1,3. Wouldn't these points, because that slope, couldn't that line be beveled any way it likes, right? Wouldn't it more likely to be 7.12345, 2 days later, 899, right? Like 1,000 million decimal places if you wanted to know exact. And wouldn't this one be equally bad? And wouldn't you have to round those guys off just to be able to physically do them? Because theoretically, at least, couldn't they go on forever? So wouldn't that not be an exact value anymore? Wouldn't this be an estimate because you've rounded them off? So you can't get the exact value for the slope of a tangent line by physically drawing what you think is a tangent line and doing rise over run. So how do we solve the problem? Well, we don't directly solve the problem yet. What we do is we do an engineer workaround. Let's find an estimate for it instead. And just get a really good estimate. And then find a process where we can make that estimate as accurate as we like. And that's sort of a half solved the problem, right? So do you want to know the slope of the tangent line? I might not be able to tell you the exact answer, but I can give you a darn good approximation, right? Something that's good to 20 decimal places. Yeah, you happy? 20 is good, right? That'll keep you happy, right? I could do that. So let's pick a physical example of that, right? A specific curve at a specific point and try and estimate its tangent line. And the curve I'm going to pick is one that I'm choosing because it's very easy. And that's y equals x squared. Right? That's basically our f of x. Are you all happy that's roughly what x squared looks like? Right. And I am interested in this point here, P. And P is at the point 3, 9. Are you happy about if x is 3, the y is 9? Okay, can you imagine these are scales that would make that work, right? Now, I am going to find an estimate for the slope of the tangent line. And I'm going to use the idea that I can choose any guy I like. So I'm going to choose Q, and it's going to have an x coordinate of 4, which means its y coordinate is 16. And I am going to find the slope of the line joining P to Q. And the notation I'm going to use is M PQ. Are you happy with that notation? Just means slope of the line PQ. Don't ask me why it's got an M there. I'm going to blame the French. Probably the French word for slope starts with an M. I mean, if you were thinking about it, wouldn't you call it S of PQ? You know, slope the PQ, if you're going to call it anything, but whatever. It's M of PQ, we'll live with it. Now, that technically is the rise over the run, which I agree. But in this case, won't that be the, well, if I put in my little dotted lines coming up and down, won't the rise be the difference in these two y coordinates? And the run going this way, won't it be the difference in x coordinates? So can you imagine the difference in the y coordinates? So that's yq, take away yp, and that's xq, take away xp. So can you imagine me calling that xq and yq, and I'll call this xp and yp. You happy about just my general notation? Right, so if I say x subset q, I mean the x coordinate of the point q. Right. Now, if you do this particular one, what do you get? You get 16 take away 9 over 4 take away 3, 7 over 1. The answer is 7. Okay, that's my estimate. Now, the real tangent line would be something more like this green line here, right? I'm not very good at drawing lines. Would you agree that this isn't the exact answer? It's just an approximation, right? It's an estimate. Well, at least I've got a start, right? So I want to get a better estimate, right? A more accurate estimate. And this is what we do. P isn't going to go anywhere, right? Because I want to know the slope at P, right? So I can't change that. But can I change who Q is? Couldn't I pick a different Q? Now, if you imagine P is fixed, well, that's 3, 9. And my first estimate Q was 4, 16. And the slope ended up being 7. Well, keep P the same, but couldn't I choose Q to be 3.1? In other words, wouldn't Q be somewhere about there? Would you agree that the line joining P to the new Q, because it's closer to P, wouldn't that be a more accurate estimate? Would that seem reasonable? Right. I have to figure out what the Y value is, so that's why we have calculators. 3.1 squared. And the answer I get here is 9.61. And I'll just do the calculation here. It's that Y coordinate, take away 9, this X coordinate, take away 3, and can you just trust me on this, but it's 6.1. So my first estimate was that the slope of the tangent line is 7. My new, which I think all of us, or hopefully all of us agree, better estimate, more accurate, is 6.1. Well, I want a more accurate estimate. Couldn't I make Q 3.01? Wouldn't that be really, really close to P now, right? Would you agree? Almost on top of it. 3.01, when you square it, is 9.0601. And can you just trust me, you can check this later, that the slope ends up being 6.01. Let's do one last one. What X coordinate could I give Q so that it's dead close to P? Pick something even closer than the ones I've picked already.
3.001.
And if you do that, which is a good choice, in my opinion, you will get a y coordinate of 0, 0, 6, 0, 0, 1. And again, you're going to have to trust me on this, but if I find the slope, it ends up being 0, 0, 1. And math, one of the things that is done in math a lot is you look for patterns. When I chose this one, the slope was 6.1. When I tried a little bit more accurate, it's 6.01. When I tried even closer, right, to be even more accurate, it's 6.001. If you were a gambling person, what do you think the exact value for the slope of the tangent line is probably going to be?
Good chance it's 6.
I would agree. Later on, we will discover that it is in fact 6. But right now, the best I can say is that that's my best guesstimate. Now you might say, well, why can't we just call it 6? Well, it's kind of like lawyer-esque. Theoretically, at least, I know in X squared it's probably not going to happen, but theoretically, couldn't the correct answer for the exact value be 6.2 billion zeros and a 3? Wouldn't you not be able to tell if that was true by doing this estimate method? Because you don't really know where to stop looking, right? It could be that the answer is 6.2 billion zeros and a 1. Right? Couldn't you spend the rest of your life just keep doing that? In fact, wouldn't calculators stop working because there's only so many decimal places they go, and then you go to a computer. But believe it or not, don't computers even have a limit to how accurate they can go? So eventually you're going to run out of technology and you still won't be 100% sure. You're probably 99.99% sure that it's 6, but isn't there a niggle that it might sometimes not be true? And so that's not allowed. We can't use that technique to tell the exact value. We can, and it is totally reasonable to say that our estimate is probably 6, right? Our best guess is 6. Isn't it also true to say that our estimate 6.001, as long as I call it an estimate, is a totally valid answer as well? So to finish with, some bright spark said, hey, I know how to fix this problem. Make P and Q the same place. So P is 3,9 and Q is 3,9. Well, if you try and find the slope joining these two together, don't you get 9 take away 9, 3 take away 3, and you get 0 over 0. There should be some raised eyebrows, shouldn't there? That is not 0, and that is not 1. That is yikes. That's what that is. You don't know what 0 over 0 is. In fact, 0 over 0 has a really annoying property that depends on where it came from, that the answer could be almost anything. So how did they do a workaround? They created a piece of math called limits. And what limits allowed us to do is to almost do this. We won't make P and Q the same. What we'll do is we'll make P and Q so close to each other that you couldn't tell that they were different. And we'll use this technique called limits to get the exact value for the slope of the tangent line. And that's where the calculus starts. Because once we know how to find the exact value of the slope of a tangent line, we have calculated what's called a derivative. That's the name they give to that. And then from there, it just went and shot out like all sorts of cool stuff got created once we got over this initial hurdle of the tangent line problem. Okay, everybody say hi because it's time.